Projectile motion. When any object is thrown from horizontal at an angle theta except 90 degrees, then the path followed by it is called trajectory. The object is called projectile. So that curved path that the object takes is trajectory, and its motion is called projectile motion. If any object is thrown with velocity u, that is the initial velocity is u, making an angle theta from the horizontal, then the velocity can actually be divided into two components since velocity is a vector. We talk about the vertical component and the horizontal component. The horizontal component of initial velocity equals u cos theta. The vertical component of initial velocity equals u sine theta. The horizontal component of the initial velocity is constant throughout the whole journey. Please take note, it remains constant. It does not change. However, the vertical component of the velocity changes as the projectile progresses. So please take note. The horizontal component, u cos theta, at the maximum height is the only component acting. So the vertical component of velocity, u sine theta, decreases gradually and becomes 0 at the highest point of the path, as we've already made mention of. So at the highest point, it is only the horizontal component of the velocity that is active or that is acting, while the vertical component is 0. We've seen this in past question. When you're given a question and you are told to find the component of the velocity at the maximum height, please take note, at the maximum height, the angle between the velocity and the acceleration due to gravity is 90 degrees. And the component of the velocity that is necessary to solve problems is u cos theta. So there are some important points and formulae of projectile motion that you must know. At the highest point, the linear momentum is mu cos theta. Remember, momentum is mass times velocity, and at the highest point, the component that is active is u cos theta, so the momentum becomes mu cos theta, while the kinetic energy is half m u cos theta all squared. The horizontal displacement of the projectile after t seconds, x is equals to u cos theta times time. Remember, the horizontal displacement is also known as what? Range. The horizontal displacement is also known as range. Okay. So theta is the angle between the words, the projectile and the horizontal. The path of a projectile is parabolic. And that path is also known as what? The trajectory. Kinetic energy at lowest point is equals to half mu squared. That is to say, the lowest point it reaches, before the point before it touched the ground, its lowest point is half mu squared. The linear momentum at lowest point is equals to mass times initial velocity. Acceleration of projectile is constant throughout the motion, and it has vertically downwards, being equal towards g. So the acceleration due to gravity is constant once the projectile is in air, and it's equals to g. It has downwards. Please take note. The direction it has downward. Angular momentum of projectile equals mu cos theta times h. M is the mass of the object, u is the what? Initial velocity, theta is the angle between the projectile and the horizontal, and h is the height. In the case of angular projection, the angle between the velocity and acceleration varies from 0 to 180 degrees. What do we mean? That is to say, the projectile can take angles from 0 to 180 degrees. The maximum height occurs when the projectile covers a horizontal distance equals to half of the horizontal range, that is r/2. It occurs when the projectile covers the horizontal distance equals to half of the horizontal range, that is r/2. So please take note. Time of flight. What is the time of flight? It is defined as the total time for which the projectile remains in the air. The time of flight is defined as the total time for which the projectile remains in the air. Maximum height is defined as the maximum vertical distance covered by a projectile. Also, horizontal range is defined as the maximum horizontal distance covered in projectile motion. What are the formulas? Total time of flight is 2u sine theta over g. The maximum height is u squared sine squared theta over 2g. And the horizontal range is u squared sine 2 theta over g. Please take note, where u, theta, and g are already known. U is the initial velocity, theta is the angle between the projectile and the horizontal, and g is the acceleration due to gravity. Please note that for maximum range, the angle is 45 degrees. Maximum range occurs when the angle of projection is 45 degrees. 3 special cases in projectile motion. Case 1. When projectile is projected horizontally. So there are 3 cases you need to know in projectile motion. When the projectile is projected horizontally, the initial velocity in the vertical direction is what? Is 0. Time of flight, don't forget that u sine theta, the angle horizontally means the angle is 0. And sine 0, of course, is what? Is 0. So the time of flight is the square root of 2 times the what? The horizontal height, the vertical height divided by g. The horizontal range is s is equals to ut cos theta. Since cos 0 is 1, we have s is equals to ut, and that translates to u, the square root of 2h, 2 times the vertical height, all over g. So vertical velocity after t seconds, vy, is equals to what? Gt. Where your initial velocity, uy, is equals to 0 as the projectile is projected horizontally. So once the projectile is projected into the air, velocity of the projectile after t seconds, v, is equals to the sum of the squared of the what? Horizontal velocity plus what? The vertical velocity. That is to say vs squared plus vy squared. And that is equals to the square root of what? U squared plus gt squared. So take note. Then we can also get the angle between the words, the initial velocity and the horizontal using tan phi or tan theta. So when the projectile is projected downward at an angle with horizontal, as you can see, the initial velocity in the horizontal direction is u cos theta, initial velocity in the vertical direction is u sine theta, and the time of flight can be obtained from the equation, the displacement equation. H is equals to u sine theta t plus half gt squared. Don't worry, we'll be looking at problems to make us understand these concepts better, how to apply the necessary equations and when to know what to do. Horizontal range S is equals to u cos theta times t for downward motion. Vertical velocity after t seconds, that is to say vy, is equals to u sine theta plus gt. So again, the velocity of the projectile after t seconds can be categorized into 2 using the Pythagoras theorem, that is your vs squared plus vy squared. And that simplifies to the square root of u squared plus gt all squared plus 2ugt sine theta. So is that simple. So what about when the projectile is projected upward at an angle with horizontal? For upward motion, directly upward, what do you think is the angle? Initial velocity is equals to u cos theta. That's in the horizontal direction now. The initial component of the velocity in the vertical direction is u sine theta. Time of flight can be obtained from the displacement equation. H is equals to minus u sine theta t plus half gt squared. So please take note. We'll also be seeing applications of these concepts, how to know when to go about that. So horizontal range for vertical motion, S is equals to u cos theta times t. Vertical velocity after t seconds, Vy, is equals to minus u sine theta plus gt